Hello everybody, welcome into another lesson. So today we are going to talk about solving exponential equations. So here you have 10 to the x minus 3 power equals 100 to the 4x minus 5 power. We need to find the value of x. Well, if you're on both sides, if your bases are the same base or if they can be made into the same base, it's real easy. And with exponential equations, remember, your domain, the values for x you can get, are all real numbers. So we shouldn't have to worry about any extraneous solutions. Now, in the next lesson, when we talk about solving logarithmic equations, that's going to be different. But for exponential equations, your domain's all real numbers. So let's look at the bases 10 and 100. Can we relate 100 to 10 at all? Yes, we can, because 100 is 10 squared, right? So this can be rewritten as 10 to the x minus 3 power would equal the quantity of 10 to the second power, because 10 to the second power is 100 to the 4x minus 5 power. And now on the right side, you have a power to a power, which is going to make this a lot easier. So then this turns into 10 to the x minus 3 power would equal 10 to the 8x minus 10 power. Now what do you know? You got the same bases. If the bases are the same, which was our goal, all you have to do is take the exponents and set them equal to each other. So we can now take that x minus 3, set it equal to 8x minus 10, and we just solve for x. So that should give you that 7x is equal to 7, which would give you that x equals 1. So the value that we're looking for x would in fact be 1. So, and if you want to check your work, you could put that value of x into the values of x in the original equation, and you'll see that it's true. So x would equal 1. I got plenty more where that came from. We have 25 to the x minus 1 power equals 125 to the 4x power. Alright, so we have 25 to the x minus 1 power equals 125 to the 4x power. Well, they're definitely not the same base, but we can relate them to be the same base. What's another way of writing 25? Well, isn't 25 the same as 5 to the second? So we can make this 5 to the second, that whole quantity to the x minus 1 power would equal, now the right hand side, can we make 125 into base 5? We certainly can. 125 is actually 5 to the third. So that would be 5 to the third to the 4x power. So then you do your exponent operations. So this would turn into 5 to the 2x minus 2 equals 5 to the 12x. All right, so you have 5 to the 2x minus 2 equals 5 to the 12x. Now we got the same bases, which means you can just set the exponents equal to each other. So you would have 2x minus 2 equals 12x. Now just solve for x. You would actually end up then getting that 10x equals negative 2, which would end up giving you that x equals negative 1/5. So the value you should get is that x would equal negative 1/5. All right, let's see. We have 3 to the x minus 7 is equal to 27 to the 2x. All right, so we have 3 to the x minus 7 equals 27 to the 2x. Well, can we relate 27 to 3 at all? We can, because 27 is 3 to the third. So this will turn into 3 to the x minus 7 equals the quantity of 3 to the third raised to the 2x power. So now all we have to do is simplify the right-hand side. So you have 3 to the x minus 7 would equal 3 to the 6x. And now we have the same base. Both bases are 3, so you just got to set the exponents equal to each other. You'd have x minus 7 equals 6x. Go ahead and solve for x. You would end up getting that 5x equals negative 7, which would end up giving you that x equals negative 7/5. So the solution you should get is that x equals negative 7/5. Now how about this one? 36 to the x minus 9 equals 6 to the 2x. All right, so we have 36 to the x minus 9 equals 6 to the 2x. Can we relate 36 to 6? We sure can, because 36 is 6 squared. So you'll have the quantity of 6 squared raised to the x minus 9 power would equal 6 to the 2x. So on the left side, perform your exponent operations. You should get 6 to the 2x minus 18 equals 6 to the 2x. Now you got the same base, just set the exponents equal to each other. So you would end up getting 2x minus 18 equals 2x. But then you would get a false statement that 0 equals 18, which is not true. 0 never equals 18. So if you got a false statement like that, that means there's no solution. In this case, there is actually no solution to x that would make these equal. So the answer to this one is there's no solution. All right, good one. We have 8 to the 5x is equal to 16 to the 3x plus 4. So this is a very good one here. 8 to the 5x equals 16 to the 3x plus 4. Well, 8 and 16 both relate to bases of 2, don't they? 8 is 2 to the third, isn't it? So you could take this quantity of 2 to the third, substitute that for 8. You'd have 2 to the third to the 5x power would equal the right-hand side. Well, 16 is 2 to the fourth, isn't it? This would become the quantity of 2 to the fourth raised to the 3x plus 4 power. So now on both sides, just perform your exponent operations. You should get 2 to the 15x would equal 2 to the 12x plus 16. Well, now you got the same bases, base 2, so just set the exponents equal to each other. You would get 15x equals 12x plus 16. Then just solve for x. You should get 3x equals 16, which would give you a value of x equal to 16 thirds. So the answer you should get for this is that x would equal 16 thirds. All right, now here's where it changes a bit. You have e to the negative x equals 6. E to the negative x equals 6. Well, here's the thing. There is no whole number power of e that would equal 6, right? Because e is approximately 2.78. So what do we do in that situation? If you have no hope of being able to relate the bases of either side with the whole number, you have to use a logarithmic function and take the inverse, because logarithmic functions are inverses of exponentials, right? So how are you going to do this? So on the left side, you'll have to take the natural log of e to the negative x, because the natural log is the log base e. But what you do to one side, you have to do to the other. So you'll also have to take the natural log of 6. And then you'll end up having on the left side the power rule. That'll bring the negative x down in front of the ln of e. That would equal the ln of 6. Well, what is the ln of e? That's just 1, right? So negative x would equal the natural log of 6, which means x would just equal negative of the ln of 6. And that's all you would be able to get. You will sometimes get logarithmic answers. X would equal the negative of the natural log of 6. And if you care to, you can get a decimal approximation. But this is technically the exact answer. If you're asked for a 3 decimal place approximation, for example, you would just input that into your calculator and get it. But there's the exact answer. X equals negative of the natural log of 6. Alright. Now we have 2 to the x equals 15. So we've been given 2 to the x equals 15. Well, there is no whole number power of 2 that will equal 15. Now 2 to the 4th equals 16, 2 to the 3rd equals 8, but there's no whole number power of 2 that will equal 15. So there's no way to relate the bases on either side, which means we got to break out our logarithmic functions. So if you have 2 to the x, we need to take log base 2 of 2 to the x. But what you do to one side, you got to do to the other. This would turn into equal to log base 2 of 15. Now on the left side, you have the power rule. You'll have x times log 2 of base 2 equal to log base 2 of 15. Well, what is log base 2 of 2? That's just 1, right? So you get that x is equal to log base 2 of 15. And that would be your exact answer. X would equal log base 2 of 15. And if you needed to, you could use the change of base formula and then put that into your calculator and get a decimal approximation. But for today, exact answers will suffice. X would equal log base 2 of 15. Alright, we have 1.2 e to the negative 5x plus 2.6 is equal to 3. So we have 1.2 e to the negative 5x plus 2.6 equals 3. Well, I think it's very important that we get that 1.2 e to the negative 5x by itself first. So subtract 2.6 from both sides, you'll end up getting 1.2 e to the negative 5x would equal 0.4. Alright, now we just want to get that e to the negative 5x by itself, so divide both sides by 1.2, you'll get e to the negative 5x would equal 0.4 over 1.2, which is the exact same as 4 over 12, which would give you 1/3. So e to the negative 5x would equal 1/3. Well, there's no way to relate the base of e with the base of 3, or 1/3, so we're going to have to use the natural log function on both sides to solve for x. So take the natural log of e to the negative 5x. That would also equal the natural log of 1/3. And then the left side, you have the power rule. That'll give you negative 5x times the ln of e equals the ln of 1/3. Well, what is the ln of e? That's just 1, right? So you'll get negative 5x equals the ln of 1/3. Now just divide both sides by negative 5 to solve for x. You'll end up getting that x equals negative of the ln of 1/3 divided by 5. And that's the exact solution. So the exact solution is that x equals negative of the ln of 1/3 divided by 5. All right. 4 to the x minus 5 equals 3. This one's actually not so bad. It looks bad at first, but it's really not. So 4 to the x minus 5 equals 3. Well, let's get 4 to the x by itself first. You got to add 5 to both sides. So if you do that, you'll get 4 to the x equals 8. Can we relate 4 and 8 at all? We actually can. They both have a common base 2, right? Because 4 is actually 2 to the second power. That's the same as 2 to the second power raised to the x power. That would equal the right side. 8 is 2 to the third. So now simplify your left side. This would turn into 2 to the 2x would equal 2 to the third. Now you got the same base, so all you got to do is set the exponents equal to each other. So 2x would equal 3, which would end up giving you that x equals 3/2. So that's going to be your answer. X would equal 3/2. Pretty cool how you can do all that. All right, we're halfway done. Okay. We got negative of 5 e to the negative x plus 9 equals 6. So negative 5 e to the negative x plus 9 equals 6. Well, we need to get that negative 5 e to the negative x by itself first. So subtract 9 from both sides. You'll end up getting negative 5 e to the negative x would equal negative 3. And then we want to get that e to the negative x by itself, so divide both sides by negative 5. You'll end up getting e to the negative x would actually turn out to equal positive 3/5. Well, there's no way to relate e and 3/5 with a base that has a whole number power, so we're stuck in a natural logarithm again. So take the natural log of both sides. The natural log of e to the negative x would equal the natural log of 3/5. So the left side, you have a power rule. This will turn into negative x times the natural log of e would equal the natural log of 3/5. Well, what is the natural log of e? That's just 1, so this will turn into negative x equals the natural log of 3/5. Then just divide both sides by negative 1 and solve for x. You'll get that x equals negative of the natural log of 3/5. So that would be your exact answer. X would equal negative of the natural log of 3/5. Okay. We have 10 to the 2x plus 3 is equal to 8. So we have 10 to the 2x plus 3 equals 8. Well, we want to get that 10 to the 2x by itself, right? So subtract 3 from both sides, you should get 10 to the 2x is equal to 5. Well, do we have any whole numbers to relate the bases of 10 and 5? We don't, so unfortunately you're going to have to break out the logarithms. So you're going to have to take log base 10 of 10 to the 2x and set that equal to log base 10 of 5. So the left side, you have a power rule. This would be equal to 2x times log base 10 of 10. That's going to equal, of course, log base 10 of 5. Well, what is log base 10 of 10? That's just 1, so this would turn into 2x equals log base 10 of 5. Then just solve for x, you'll get that x equals log base 10 of 5 divided by 2. So the exact answer is x equals log base 10 of 5 divided by 2. All right. I have about 7 more. Good one. 0.25 to the x minus 0.5 equals 2. So we have 0.25 to the x minus 0.5 equals 2. So let's get that 0.25 to the x by itself first. That's going to end up equaling 0.25 to the x would equal 2.5. Alright, so then let's see here. There's really no direct way without using decimals to relate the bases of 0.25 and 2.5. So now actually there is, I'm sorry. So because what is 0.25, okay? What is 0.25? Isn't that the same as 25 to the negative times 10 to the negative second? So that would be, let's see. So you could take 25 to the x times 10 to the negative second. No, that's not going to work. I was hoping there was a way to relate them, but there really isn't. Okay, so 0.25 to the x. So take the log of those bases to both sides. So log base 0.25 of 0.25 to the x would equal log base 0.25 of 2.5. Well, now the left side will turn into a power rule, so you'll have x of log of log 0.25 of 0.25 equal to log of 0.25 log base 0.25 of 2.5. Well, what is log base 0.25 of 0.25? That'd just be 1, right? So you would get x is equal to log base 0.25 of 2.5. That would be the best way to do this, unfortunately. You got a rather hideous answer, but that's the exact answer. X equals log base 0.25 of 2.5. The decimal ones can get a bit tricky at times. Alright, now here's a good one. 1/4 of 4 to the 2x plus 1 equals 5. Alright, so we have 1/4 of 4 to the 2x plus 1 equals 5. Well, go ahead, get that 1/4 of 4 to the 2x by itself. So if we do that, this will turn into 1/4 of 4 to the 2x would equal 4, right? Now we can get that 4 to the 2x by itself, multiply both sides by 4, you'll end up getting 4 to the 2x would equal 16. Well, we can definitely relate 4 and 16, can't we? That's the same as 4 squared. So you would have 4 to the 2x would end up equaling 4 to the second. We now have the same base, just set the exponents equal to each other. You'd have 2x equals 2, which would give you that x equals 1. So the answer you should get then is that x equals 1. That one actually wasn't as bad as it looks. It just looked worse than it was. All right, 5 more. Let's see, we have 2/3 e to the 4x plus 1, I think it's plus 1/3 actually, yeah, plus 1/3 equals 4. So we have a bunch of fractions in this too. So we have 2/3 e to the 4x plus 1/3 equals 4. Definitely want to start out by getting that 2/3 e to the 4x by itself, right? So this will turn into 2/3 e to the 4x would equal, so what is 4, which that's 12/3 minus 1/3, that would be 11/3. So 2/3 e to the 4x equals 11/3. Alright, multiply both sides by 3, so you would get 2e to the 4x would equal 11. Now let's get the e to the 4x by itself, so you would end up getting e to the 4x equals 11/2. Well, there's no way to relate base e and base 11/2, so we're going to have to use logarithmic functions. So take the natural log of both sides. The ln of e to the 4x would equal the ln of 11/2. So then you have a power rule on the left, that'll just turn into 4x times the ln of e equals the ln of 11/2. Alright, so what is the ln of e? That's just 1, so I'm going to move over here. You'll literally get 4x equals the natural log of 11/2. And then solve for x, just divide both sides by 4. You'll get x equals the natural log of 11/2 over 4. So that should be the exact answer you would get. X would equal the natural log of 11/2 divided by 4. Kind of a hideous answer, but that's what it is. 4 more. All right, we have 10 to the negative 12x plus 6 equals 100. So we have 10 to the negative 12x plus 6 equals 100. Well, let's get that 10 to the negative 12x by itself first. So we'll end up getting 10 to the negative 12x would equal 94. Well, there's no whole number to relate 10 and 94, unfortunately, so we're going to have to break out the log base 10 of both sides. So take log base 10 of 10 to the negative 12x, set that equal to log base 10 of 94. Well, the left side, you have a power rule. You'll have negative 12x times log base 10 of 10 equals log base 10 of 94. Well, what is log base 10 of 10? That's just 1, so you end up getting negative 12x would equal log base 10 of 94. Now we can solve for x. You end up getting that x equals negative of the log base 10 of 94 divided by 12. And that would be your exact answer. X would equal negative of log base 10 of 94 divided by 12. I have 3 more. All right, 4 minus 2e to the x equals negative 23. Well, let's get that negative 2e to the x by itself. Actually, let's switch them around. Let's get the 2e to the x by itself. If you do that, you would end up getting 2e to the x would equal 27. And then, of course, we want to get e to the x by itself, so that would give you that e to the x would equal 27 halves. Now, there's no whole number power of e that will relate it to 27 halves. There just isn't. So we're going to have to bust out the natural log of both sides. So take the natural log of e to the x, set that equal to the natural log of 27 halves. The left side, you have a power rule, so that'll turn into x times the natural log of e. That would equal the natural log of 27 halves. Well, natural log of e is just 1. You're literally left with x equals the natural log of 27 halves. That's what you'd end up getting, is that x equals the natural log of 27 halves. I have 2 more. All right, I have 3 to the 0.1x minus 4 equals 5. So I have 3 to the 0.1x minus 4 equals 5. Well, let's get that 3 to the 0.1x by itself first. So this will turn into 3 to the 0.1x would equal 9. Well, this actually isn't as bad as it looks. Can we relate 3 and 9? We sure can, because 9 is 3 to the second power, right? So this would become 3 to the 0.1x would equal 3 to the second power. Now that we have the same bases on both sides, just set your exponents equal to each other. So you'll get 0.1x equals 2. Then we solve for x, so you're going to take 2 divided by 0.1, which is the same as 20 divided by 1, which should just give you 20. So the value of x that you actually should get would end up being 20. Should just have 1 more, then we'll be done with this lesson. Oh, good one. Negative 16 plus, real fun one, nah, not quite parenthesis time yet, plus 0.2 times 10 to the x equals 35. This one looks like a nightmare. So we have negative 16 plus 0.2 times 10 to the x equals 35. Well, let's get that 0.2 times 10 to the x by itself. So this will turn into 0.2 times 10 to the x equals 51. Well, okay, let's get that 10 to the x by itself. Divide both sides by 0.2. You would get that 10 to the x equals 51 divided by 0.2, which would actually be 510 divided by 2. What is 510 divided by 2? That's going to be 255. So now you have 10 to the x equals 255. Okay, well, there's no whole number power that could relate 10 and 255, so we have a logarithmic thing we have to do. So to get x, we're going to have to take the log base 10. So log base 10 of 10 to the x would equal log base 10 of 255. So the left side, you have a power rule. This will become x times the log 10 of 10 equals log base 10 of 255. So what is log base 10 of 10? That's just 1. So literally you get that x equals log base 10 of 255. And that is your exact answer. X equals log base 10 of 255. So that's it for this lesson. Next lesson, we're going to solve logarithmic equations, at which point we will have to worry about extraneous solutions. So I hope everyone has a great day. Take care.